All right, has to be a pretty quick one because I got to get going to a meeting here, but I know that a few people are going to be gone. And so this is this is called the zero product property. Wanted to take a look at what happens when instead of having an expression, we have an equation. In other words, it's going to be equal to something, and we want to be able to solve that. So we call this the zero product property. And so as it turns out, a very important little feature of this of multiplication is that if I gave you any number like 40 or 30 or 28 or any number, there's really, if I said, hey, I've got two numbers that multiply to 40, you could say, well, it could be 2 and 20, or it could be 5 and 8, or it could be negative 2 and negative 20, or it could be 1/2 and 80. I mean, there's a million different things that it could be. And so like we literally don't know anything unless we say that our product is zero. And one of the things about having a product of zero is, although I don't know one of the numbers out of the two, I definitely know that one of those values has to be zero. It's going to be 0 times something. So at least I know one of the two numbers here, and I don't know either of the numbers in these cases because there's an infinite number of possibilities, which is why we study very heavily what's called the zero product property. So in context of quadratics, we do stuff like this. Let's say we had a product that we factored a problem to something like x minus 4 times x plus 5 is 0. Now, again, this is a product. It is x minus 4 times x plus 5. So this is a product of 0. And the only way that a product can be 0 is if either one of the one on the left is 0 or the one on the right is 0. Now, of course, this turned this quadratic problem, which has its second degree, into two first degree problems. And if we added 4 to both sides, I would find out that x is 4. Now, keep in mind, if I plug 4 in, 4 plus 5 is 9. 4 minus 4 is 0. And 0 times 9 is, in fact, 0. See, that satisfies this problem. So that means the value x equals 4 would be a solution to this equation, this specifically quadratic equation. And similarly, if we subtracted 5 from both sides, we'd find out that x equals negative 5. And for the same reason, if I plugged in negative 5, I would get actually a negative 9 on the left side, but I'd get a 0 on the right side. And of course, the product of negative 9 and 0 is 0. So the two solutions right here are x equals 4 or x equals negative 5. And that's called the zero product property. And generally speaking, people get pretty quick at this. So let's say we had something like x plus 7 times x plus 2. And so we would, again, set each of those values to 0 and just solve the simple equation. Subtract 7 from both sides or subtract 2 from both sides. And I get these two solutions of negative 7 or negative 2. Those are the two values of x that would actually make this story true. Now, when the problem is already factored, it's awesome. It's super easy to do. But sometimes it is not factored. So let's imagine instead of this problem, we made it a little teeny bit harder, where we were talking about something like x squared minus 2x minus 48 is 0. Now, again, it's set equal to 0, which is actually a very helpful thing for us. But what I'm going to do is I'm going to look at this left side, and I'm going to do a quick diamond on it. Remember, a times c is negative 48. The middle number is negative 2. And I need to come up with two numbers that multiply to negative 48 and yet have a sum of negative 2. And the two numbers that would do that would be 6 and negative 8. Now, since the number a right here, the coefficient a is 1, then I could actually write it very quickly as x plus 6 and x minus 8. And I think most of you watching this video or sitting in class would see very, very rapidly that this is pretty easy to do, because if you set x plus 6 to 0, you're going to see right away that x has to be negative 6. Or x minus 8 is 0, you would have x equals 8. Now, what you'll notice, though, is frequently people will just start skipping this step right here and jumping straight on down, because If this is 6, in order to get 0, I need the opposite of it. If this is -8, I need the opposite of it. So you can really look at the factored form and immediately write down your answers, which makes it great, makes it super duper easy. Now, sometimes we're not that fortunate to have a problem that is actually set up correctly quite so well. And sometimes you have a problem that maybe looks a little bit different and it doesn't look like the zero product property. And again, I don't want to go quite so fast that I go too quickly for everybody, but let's say I have this problem right here and I want to know when is x squared minus 4 the same as -3x. Well, that's a problem. Like, I don't know how to figure that out at all. So what we're going to do is I'm going to add 3x to both sides. Now, the original problem doesn't look like it, but now if I rewrote it in this way, all of a sudden I have something just like this previous problem that is perfectly compared to 0. That's a critical piece of algebra. Anytime you have a quadratic, we like to set those things equal to 0. And now I could do my little magic X or my diamond problem, depending on who you talk to. And so I know that 4 and -1 would have that proper product. So remember, please don't try to jump to your answer yet. Write it in factored form first. And so the factors would be x plus 4 and x minus 1. And therefore, my two solutions would be x equals -4 and x equals +1. Now, this looks like a hard problem, but let's just double check something real quick. Let's look right here. What would I get if I squared -4? Well, I'd get 16. -4, and I'm asking, did I do this problem right? What would happen if I plugged -4 into the left side and also plugged it into the right side? Well, I'd get 12 here, and I'd also get 12 right here, which kind of shows you that I did that right. But of course, I could also plug in 1. Excuse me. So if I took 1 and I squared it, because that was my other solution, 1 squared, of course, is 1, -4, is that the same as -3 being also multiplied by the x value of 1? Well, is -3 the same as -3? Of course it is. And since I know that there should be two solutions to this problem and they both work, that confirms that I got my question correct. Okay, now that's a very quick video. I'll have a follow-up video at a later moment where we'll talk about what happens when our leading coefficient isn't 1. It's not really all that different, but there's a tiny little change to how we actually do the math. It's literally just one extra step, which isn't that bad. And anyway, hopefully that was helpful, and I will see you back in class. Bye-bye.